Okay, so you want a zero point 0.2 farad capacitor, right? Now, first understand that a 0.2 farad capacitor is just a giant capacitor. We want to do it with a 2.2 millimeter air gap. So our distance, the distance separating the plates, is 2.2 times 10 to the minus third meters, right? We want our capacitance to be 0.20 farads, right? And then we want to figure out the area, right? Now, it's an air gap, and we're going to assume that air has the same electrical permittivity of free space, right? Which is approximately true, right? So our formula is C is equal to, and then it's area divided by the distance. So the farther apart they are, the less the capacitance. And that's because what they induce, it's harder to induce a charge on the plates, right? You've got these plates like this, right? And the closer they are together, the easier it is to put charge on the capacitor, the more capacity it's got, because they're close to each other and they induce charges on each other more easily, right? And obviously the bigger the plates, the more area. It's just directly proportional, right? What you're going to use for the emissivity, so this formula, by the way, is on page 9 of the data packet. And then if you look inside the front cover, we're going to use the permittivity of free space, okay, which is 8.85 times 10 to the minus 12th, right? And that's coulombs squared, newtons to the minus 1, square meters to the minus 2, right? Which just, was going to cancel out and give you farads ultimately, right? Okay, yeah. All right. What else do you need to do? Oh, you're going to put this, the 2.2 times 10 to the minus third in for there. You're going to solve for the area, right? Now, I'm pretty sure that area, that 5 times 10 to the 7th, right? That area is like 7 kilometers on a side, right? This is a little bit too big for putting inside any package that we might have, right? And so 7 kilometers on a side. What we do, the answer is that we don't make, if we want a capacitor that big, we don't use air between the plates, right? We fill it with a dielectric that's got a much higher permittivity, and therefore the area gets to be smaller. Anyway, happy hunting.